Hi everyone, my name is Garyfallidis. I'm a PhD student at Indiana University Bloomington in the Intelligent Systems Engineering Department. Today I'll be presenting on the topic of denoising. I will be focusing on partial self-denoising, which is a new self-supervised statistical independence-based denoiser that we have developed. I have structured the presentation in three parts. In part one, we will look at partial self, how it works, how it is implemented in Dipy. In part two, we'll look at matrix sketching, essentially a faster approach to denoising, essentially how you can use randomized numerical linear algebra as a system which reduces the memory footprint and speeds up the denoiser. And in the third part, we look at noise uncertainty quantification, which is an image quality analysis metric that we have developed to essentially quantify the effect of noise on a single subject and at a group level. Before we get into partial self, I just want to lay out the different approaches to denoising diffusionmri. The first one, and I think this traces back to 1992, is a total variation norm, where essentially one assumes that the signal is locally or globally smooth and fits a line or a spline to your data to essentially smooth the signal out. The second one is low rank approximations, and this is very common in diffusionmri, either via local PCA or marginal capacitor PCA, where essentially you truncate the rank of the data, meaning that you threshold the singular value spectrum of your data such that you discard the noisy singular values. The third one is self-similarity, where essentially you assume that the signal is locally or non-locally smooth, and you take either a mean or some type of nonlinear transformation to essentially denoise the data. The fourth category is sparsity. So this is based on dictionary learning, wavelet transforms. Essentially, what we're saying is that you can represent the signal, like the entire signal, that is the image, in an overcomplete basis, and you can reconstruct the entire image from the sparser basis set. And the fourth category, which is what partial self belongs to, is statistical independence. So as opposed to the four denoisers that I explained before, partial self does not make an assumption on the signal. So it does not assume that the signal is smooth, low rank, self-similar, or sparse, but it rather makes an assumption on the noise. It says that noise is randomly fluctuating, it is uncorrelated across gradient directions, and we look at this in greater detail in the videos. And we have MPPCA, non-local means, and partial self implemented in Dipy. Today, I will not be covering these. I have already presented these in last year's workshop. So if you just go to YouTube, search for Dipy workshop, a playlist will pop up that says Dipy workshop 2021. And in there, you can find these videos on non-local means and PCA and how to use them in Dipy. Okay, see you in the next part.